Welcome back, everyone. I've been consuming a ton of my fellow content creators' videos, and I typically dip into the comments. I'm always evaluating other printers and brands, and I've seen some reoccurring things that make me wonder what is truth versus conjecture. Often I see obvious comments that can be debunked in a few minutes, but occasionally I see things being said that are taken as facts with little to no research. Not being one to take things at face value, I was curious if this common knowledge is actually accurate. So let it be known now, I have a Bambu Lab X1 Carbon with AMS. I print multicolor items on a regular basis. The most common negative about printing with an AMS is that 1, it poops and it's harmful to the environment, 2, the printing is slow, and 3, it is massively wasteful, and you will have more in filament waste than the actual printed model. And with that, you're spending big bucks just in waste. While I won't deny the printer does relieve itself out the back, and I think we have all gave Mother Nature an enthusiastic blowing raspberries printing with plastic. However, you can decide what to do with that excess plastic. As for speed, many filament changes can and will increase the overall print time. There are easy mitigation steps depending on your model. The filament waste part is a little more complicated, and in some cases not accurate at all if you make some small adjustments. So I've been running some experiments about multicolor printing. So let's talk about filament defecation. On multicolor or multi-material printers with a single nozzle, the printer needs to expel this filament somewhere before switching to another filament. Bambu Lab printers with AMS typically cut, retract, replace, and purge or yeet the last filament before going into a prime tower. I say prime tower instead of purge tower, as the printer doesn't need to purge the filament again, since it already did that out the back. But it is recommended to equalize the pressure in the nozzle before going back to the print, hence the prime tower. This should eliminate things like stringing, filament blobs. We will revisit this prime tower later in the video. The X1 series printers, through firmware and slicer updates, have a neat addition that was released in April of 2024 that retracts a bit of the filament before cutting and thus not need to purge as much. But you can net a 30 to 50%, or sometimes better, filament savings though. What this does is massively decrease the amount of purge material. I don't want to get too far off track, but we should briefly go over layers and colors as they factor into this as well. Let's assume you're using defaults for everything. 0.4 millimeter nozzle, 0.2 millimeter layer height. A single layer is 0.2 millimeters high, while a 0.6 millimeter model is 3 layers high. 1 millimeter model is 5 layers high, and a 2 millimeter model is 10 layers. There could be more to this if we want to get technical, but we will keep the numbers and settings simple. Now let's quickly go over how to view your flushing volumes and make adjustments. So starting with whatever colors you're using, if you click on the flushing volumes at the top, within this, you're looking at all the colors that you've selected over here and what it takes to transition from one color to another. So if I go from gray to gray, same color, doesn't need to flush anything. In this case, if I go from gray to black, it needs to flush out essentially 122 millimeters cubed of filament. Now, typically, if you go from a darker color, so for instance, if I'm going from, let's say, black over to white, I need to actually flush out more in order for that transition to go through. So again, going from black, need to flush out a lot of white to get to the full transition to avoid any contamination. Now, if I need to change any of the flushing volumes, you can usually do it pretty easily here. So while we can manually type in our numbers, the multiplier makes it a little easier. So for instance, if I wanted to cut all of this in half, I can do a simple 0.5. I can hit recalculate, and it will cut all of these down to 50%. And you can lower this or raise this depending on your model. I created this simple calculator only because I was curious what the true cost of this wasted filament. So this calculator will have us looking at 1,000 grams or 1 kilogram roll. And let's say that that particular roll is $25. And the cost per gram is a little less than 3 cents, so about 0.025 cents. And at a 100% flush volume, I was playing around with changing colors. In worst case scenario, it was roughly 0.88, but I rounded up to 0.9. And it would give us roughly 1,100 filament swaps before it burns through an entire roll. And that would be roughly 2 cents color swap. If we took this to a 50% flush volume, we are then looking at worst case scenario of 0.2 grams, in which case the cents per swap is less than a penny, and we're getting roughly 5,000 swaps. Now, I can play around with these numbers. So let's say I had, a really expensive roll of filament at $100 per gram, in which case it's about 10 cents per gram. And worst case scenario hasn't changed, so we still get the same number of color swaps, but it would cost us roughly 9 cents. And if we were going to the same flush volume of 50%, it would cost roughly 2 cents. Now, I actually get my filament in bulk, and it costs roughly $10 for a kilogram roll, and it's even cheaper. So I'm looking at roughly a penny per gram, and less than a penny for a color swap, even on the 100% flush volume. And again, still would take roughly 5,000 swaps before I burn through a roll. Now, this is just filament swaps. It's obviously not the model, but if I was just doing swap after swap after swap, not going into a prime tower and not going into a model, that's roughly what we're dealing with. So the amount of money you're actually spending per swap just to kill a roll would, you're looking at, 1,100 swaps or 5,000 swaps. So just to put everything in perspective. So if you're curious how I came to those numbers, it's actually really simple. Just go into your slicer, paint your model, and then go into preview. Currently, we are set to the 100% flush volume. And from here, we're just going to do a simple calculation. So we're going to take the total number of grams being used and divide it by the number of filament changes. So if we just take this particular one and we'll go, I'll round up, 77 grams divided by 191 swaps. So we would use 0.4, an average of 0.4 grams per filament swap. Now, if we were to change the actual flushing volumes, so if I were to go into the flush volumes, and let's say we knock this down to 50%, and of course make sure that you both recalculate and hit OK, and then we will refresh this. And let's do the same thing. So right now we have a total of 37 grams being used, so 37. We would divide this by the 191 swaps, which would bring us down to a little less than 0.2 or 0.19 grams per swap as an average. Okay, so we'll create a model for our experiment. So I'm going to start with the primitive, and we will do a cube, and we'll make some adjustments here. So we'll do 50 by 50, and we'll make it 2 millimeters in the Z height. And of course, we'll make sure everything's centered, which should be good. All right, so let's create a cylinder. So right click, cylinder, and we'll make this black, and let's hit 2 to make that black. All right, so we'll also shrink this down to 2 millimeters, and I'm going to center this. We'll hold Control or Shift, select both of these, right click and merge. It used to be called Assemble. All right, now let's do a quick slice. All right, so what we're looking at here, the model total weight would be roughly 5.67 grams. The total amount that's flushed would be 4.63 grams, and the prime tower is 1.17 grams, for a total of 11.47 grams. All right, so this will be our starting point. So we'll actually make some clones of this. All right, and we will make an adjustment, and we will lower the flushing volumes, and we'll just knock it down by 50%. Oops. So we'll do 0.5. So this should have all of the flushing volumes. Hit OK, and we'll do a slice plate. All right, so this is what we're looking at here. So the actual model weight is about the same. Flush volume's obviously dropped, and the tower isn't that much different. But we did drop roughly 2 grams off the top. All right, so that's actually not the only thing that we can do. And actually, I sort of jumped ahead. So one of the things that we can do as well is make sure that we turned on the long retract option. I'm actually going to run these tests without the long retract, but I'll show you where it's at. So if you have the latest version of Bambu Studio, you can go into Preferences, scroll all the way down to Developer Mode or Develop Mode. And then from here, you would go into your printer model. And I believe only the X1 Carbon has this. Anyone with a P1P or P1S, you can see if this is there. You can go under Extruder, and then you can turn on the long retract when cut. We're going to leave this off for right now, so I'm actually curious to see how well we can push the normal flushing volumes. Now, going into another thing that we can do is we can actually, I'm going to test how this would work if we get rid of the prime tower. So if you ever want to get rid of the prime tower, you want to make sure you're in global process. And then if you scroll down, prime tower, you can turn off. Now, the prime tower is good for 2 things. One, it can equalize the pressure in the nozzle after filament changes. The other thing that it can do is if you're doing a print with a different time lapse called the smooth time lapse, you actually have to turn that on. So the main differences between the prime tower when you do it with a filament change or if you do it with the time lapse, if you switch it to the smooth time lapse, it has to make a sort of a movement and a priming of the tower basically at the height of the model. So if this model's 2 millimeters, it has to be 2 millimeters versus if the color changes, let's say stops at 1 millimeter, that's how high the prime tower would be. So just keep that in mind. If you want to do a smooth time lapse, you have to turn on the prime tower. But in this case, we're going to do a traditional and we're going to leave the prime tower off. So let's take a look at our filament usage. All right, so we dropped roughly another little over 1 gram. So the flush volume, again, is about the same. The model weight's about the same. And we dropped from roughly 11 grams down to about 8 grams. All right, so we'll print out a few of these, one at 100%, the other one at 50%, and we'll do one at a without the prime tower. And we're going to see if we have any color bleed or any contamination of one color to another. I have purposely chosen transparent filament and a dark color to show us any filament contamination between dark and light colors. When looking at the flush volumes, Bambu Lab purges are set aggressively high on default settings, but it won't be an issue in every case. Here are some examples. This was a community post using just 2 colors, black and white. If the base color is black and the image is white, a single layer for the white may not be enough to avoid color bleed. Did you guess correctly? So let's try another model. Here's a gray item with a black image. How many layers were needed to avoid the color bleed? And oddly enough, as I tried to figure out which one was which, even in a blind test, couldn't tell which one looked best. Each of these small tests give us an idea how much we can purge and still receive a decent end product. Now let's look at that little block that shows up when you produce a multicolor print. This is the prime tower, and it can show up for a few reasons. If you're using the smooth time-lapse function, every layer the print head will park at the waste chute, take a photo, move to the prime tower, then back to the model. This makes a very clean time-lapse that looks like your model is growing. Another reason is when you use multicolor prints. The block will be as high as your last color transition. So as I mentioned earlier, the prime tower equalizes the pressure inside of the nozzle. This will help issues that would cause print blobs or even stringing. So that small bit of filament that's going from parts of your model to other parts of your model. Now, some stringing isn't a big deal, as you can usually just rub it off with your finger or hit it with a hot air gun and it will just disappear. There's other types of stringing which are thicker, which can sort of mar the surface of your prints, which we try to avoid. Now, this model is a very simple stringing test. What ends up happening is once you get to the posts here, it will bounce from post to post, and if your retractions and other settings are correct, you should have a clean post on either side without seeing filament blobs or stringing in between the two posts. Now, when we have a prime tower, what will end up happening is every single layer, whether it be a blue, a white, black, or gray, will usually be represented over on this side. Now, there's a few things that we can do with that prime tower. The first thing, we can actually change the size. So at the moment, the width is 35 millimeters and the height is 45, so, or the volume is 45. If we set this even at a low number, let's say 5 and 5, and slice, we essentially shrink that tower, and of course we would use less filament. Another option that we have is we can actually remove it completely, which is just a simple turn it off, slice, and now what we end up having is essentially just the model and its initial flush. So I'm not really focused so much on the flushing on this. I just want to make sure that as we're using this, will we get any kind of stringing, since without a prime tower, what would end up happening is, again, the nozzle will change colors. It won't prime or won't equalize the pressure, but we'll go from the chute all the way to the model. And technically we should get some stringing. So we're going to take a look and see how that is. Now we will take some things we've learned in the previous section and actually apply it to a model. All right, so this particular bear I saw on another YouTuber's channel, and she actually printed this and apparently hit about 150 grams of waste, and the print took about 10 hours. And I was curious to see if we, just apply some of these basic tweaks just to see where we're at. So right now on a simple, 100% flush, without doing any changes to the prime tower or anything like that, we are looking at roughly a 9-hour print, and we will have a model that's roughly 57 grams. And if we start adding up the flushed amount, which is 98, and the tower, which is about 18, we'll have a total of 174 grams. All right, so let's start applying some of these changes, and we'll see what we get. All right, so first what we're going to do is go to the flushing volumes. Just do a simple 0.5. I've been choosing 0.5. I mean, obviously you could choose anything you like. Even right now it's recommending, 63. And we're going to make some other adjustments as well. So we'll just start with this one with a 50%, because it's a nice round number. All right, so we actually just shaved an hour off the time, and we dropped our flushed amount drastically, and as well as the tower. All right, so what else can we do? We can, of course, shrink the prime tower. So let's say, well, we'll do 10 and 10. Do another slice. And we've dropped our flushed amount as well as our tower amount drastically as well. So we've already seen a huge difference in the amount of filament used. And of course we can just take out the prime tower altogether and see where we're at. And killing the prime tower altogether dropped us down drastically. We're actually under 100 grams. All right, now earlier in the video I made mention of one of the new features that was added, at least to the X1, not sure about the P1 series, and that was the longer track. So if we were to go back into that setting, we'll make sure it's on. So we're going to go to Preferences. All right, we'll make sure we're in the Develop mode. We'll then go to our printer, extruder, make sure that the longer track when cut is on, and looks, at the moment you'll get a an alert saying that you could have issues with clogging and such, so be careful with this. And we'll keep the retraction distance at 18, which is its default. All right, and much like Icarus, we will fly close to the sun. I'm going to knock this down to a 0.3. And I will actually keep the prime tower only because I want a smooth time lapse. So this will go the entire height of the model. I'll sacrifice a few grams. Okay, so we should have a model that's about well, the same weight as the other ones, and we have a low flushed amount. We went a little over 100 because I made the prime tower higher. But otherwise, we'll print it and see how it turns out. These are some surprising results. The transparent filament showed the most flaws when mixed with darker colors. Using the no tower in this case was met with color contamination at 50% flush, so I would recommend upping the purge amount a bit when transitioning from dark to light colors. 63 millimeters cube seemed to be the recommended minimum, but I would bump it up some, maybe 75 all the way up to 100 to be on the safe side. If you aren't comfortable manually setting in amounts, you can select auto flush to 0.6 or 0.65. I've tried that before and it works well. A small prime tower can be just as effective as a large one. So 5, 10, or 15 millimeters wide with a volume of at least 10, 15 worked well. This can greatly reduce the amount of filament not going into a model. Now, the new retraction option was the most surprising. The purged amount and the model were much lighter than the slicer settings showed, but it came out great. The weight could be fixed with simple tweaks like changing line width for infill or even the outer walls. When I originally started this video, I was actually going to do a comparison between a tool changing printer and one of the Bambu lab printers. Now, what have we learned from all of this? If you think buying a $4,000 tool changing printer to save on waste, you would need to have a few 100,000 color swaps to a million before you even break even on that initial printer's cost. That could be hundreds of rolls of filament printed before you squeeze out a drop on the higher price printer. Filament waste makes a great topic on YouTube, but if you truly cared about the waste, there are a ton of ways to reduce it, recycle it, potentially reuse it with silicone molds. You could print colored items separately and assemble later. You can print multiple cloned items as the purge amounts to the exact same. You can make sacrificial purge items by purging into infill. You can reduce the flush settings. You can reduce the prime tower. Heck, you can even just paint your model. So this video was a huge undertaking. And while you would think that just changing a few settings here or there, I just really wanted to be sure I was doing the right thing and wanted to make sure that all of the common knowledge and all of the things that I'm seeing around YouTube, in Reddit and, Discord and a few others were actually accurate, where this purge amount, this wasted filament is just, it's terrible. And yes, the environment certainly doesn't need any more plastic, but I think we all committed to having waste once we got our 3D printers. So I want everyone to just take a breather, take a step back. And I just want everyone to realize, like the Brits say, you can be penny wise and pound foolish, or as I like to say, you can step over dollars to pick up pennies. Thanks for watching.